Okay, so this is about justifying my reasoning in a 2-column proof. So we have been doing some 2-column proof, but we've just been proving a whole lot of stuff. So just to get us used to the pink sheet. So we're going to now try to go in some kind of order in order to prove really just one thing. Instead of trying to find every single angle in a picture, we're just going to be trying to find certain things. So you do need your colored pencils, obviously. Please pause the video and update your table of contents. Make sure you have this line H, reasoning and proofs, on page 18. And when the foldable's done, that's where this baby's going to be glued. Okay, so you can pause at any time. I'll kind of talk fast, and that way you can pause if you need to catch up with the writing or if you need to rewind and repeat something that I said. So when we're writing proofs, we have a process. These are the steps that we want to go through. So we have step 1. We want to draw a diagram if it's not provided and mark up the diagram. In other words, label anything that they say, just like we did when we did our practice. The next step you're going to want to do, remember, don't say, hey, I don't understand how to do this when you haven't even filled in all the information on your picture or even drawn a picture if they didn't give you one. State the given information. So remember to write down your givens. Don't forget about those. Remember, the givens can be like words, right? Or they could be in the picture, right? Remember when you mark stuff up to try to use some colors, right? Because things are going to stick out if you have colors. And you know when our pictures get busy, it's really hard. Our next step after that is to read and figure out what our end goal is. Like, what are we trying to prove? Because these ones are going to have specific end goals. And then the last one is, what is our plan to get there? So after you label everything and take a look at it, you might want to be like, I think I could try to find this other angle and then see if it adds up to something, or whatever your idea is. Now here's an example. So it says, mark the diagram and answer questions about the following proof. So we're going to go through our steps. So the very first thing we want to do is mark up our picture. So let's read it. It says, mark the diagram and answer the questions about the following proof. So it says, given ray FD, so that is F to D. That's this ray right there. Remember, a ray has an endpoint, and then it consists of all of these other points forever and ever in one direction. That is a ray bisects angle EFC. So we have E to F to C. So that's this big angle. So ray bisects. Now remember, what does bisect mean? It's going to cut it into 2 equal pieces, right? 2 congruent parts, 2 equal pieces. 2 equal parts, whatever you want to say. So it's cutting this, and you can actually see this. Do you see how this piece is equal to this piece? Like if these were 2 pieces of pizza, they'd be exactly the same size. And I just marked them with matching tick marks. So that way when someone looks at this, they're like, hey, single tick, those 2 are congruent. The next statement says, FC bisects DFB. So F ray FC, boom, bisects D to F to B. So start at D to F to B. Once again, bisect, cutting into 2 congruent pieces. So that means that this piece, I'll make a double, big fat arc, double arc. Well, it's supposed to be a double arc, but it kind of blended together. I'll make these 2 matching double arcs to show that this piece of pizza right here matches this piece. Now let's stop and think about that. We want to prove. Now this is what they want us to get to at the end. This is the only thing we have to prove. Now we might have to say some other stuff in order to get there. We want to prove that E, F, D. So that's E to F to D. That's this angle right here. I should use a highlighter maybe. This one is congruent to C, F, B. Okay, so if you take a look at this, we want to prove that the yellow one is congruent to the yellow one. Now we know this pink one's the same as this pink one. We know this green one's the same as this green one. So does it kind of make sense in your head? If this one's the same as that one, like think about this. If this was, say, random 40 degrees, then the two pinks match, right? But then this is a green one that matches the other green one. So wouldn't they all have to be 40 degrees then? So it kind of does make sense that it would work, right? So we need to figure out how we can prove that. Okay, so here's what they did. They first, remember this is your step one right here, right? Step one, you're going to draw this in here. Now step two, what did they tell us to do? State the information in the given. So here's what they did. They stated the information that was given. Do you see how this was given in the picture? And in the words? Not in the picture. It gave in the words. So they stated the given. That was your step two. What's step three? What is our end goal? So that is what I was just talking about. We kind of thought about what we wanted to try to do. Our end goal is these, we want to match these two yellow ones. So at the end of our proof, that's what we want to happen. And then we kind of got a plan to get there, which was my idea in my head of doing, okay, if this one equals that one, then that one, and that one equals that one, then they obviously must be equal to each other. So here's what they did here. They stated some angles congruent to each other. So this right here is the two pink ones congruent to each other. And they also stated that these two green ones are congruent to each other. And they used definition of angle bisector. Remember? Because bisect meant two equal pieces, so that means that they are congruent. And that is on your pink paper in the very first section. Definitions are all in that very little first chunk of angle bisector. And then, after that, they said that they were equal in measure. Now, remember, congruent and equal in measure mean the exact same thing. But when you're talking about a measure, you have to use equal. And when you're talking about congruent, you don't need the little baby m. So these two lines actually mean kind of the same thing, right? And the reason is because they are congruent. So since they were congruent right here, that meant that they must be equal, right? Because that's what the definition of congruent is. Now this right here is the transitive property. So let's talk about the transitive property. That is on your pink sheet on the bottom left-ish. Transitive property says this. If A is the same as B and B is the same as C, then wouldn't it be true that A has to be the same as C? That's actually what the transitive property is. It says if A equals B and B equals C, then A has to equal C, which is kind of what we just talked through up here. So that's how they use the transitive property here. And you can see transitive property. We're going to practice seeing transitive property because you can see transitive property because if you have two statements, you have a match. So if I look over here, you see how A is the same as B. You see how this matches and this matches? These two match, right? And so the resulting statement is the leftovers, the A and the C. So you basically take out the match. So if I look at this, it says EFD equals DFC, and DFC matches CFB. So do you see how this and this match? So when those match, you can literally just take them out. So I can just take this out of the situation, and you see how they matched up the two leftover guys, and that's what they got in this line here. EFD is equal to CFB. So you take out the match, just like this. Take these out, and you're left with the A and the C, and that's going to be your next line. That is an example of the transitive property. Definitely write that down somewhere because we're going to use that one a lot. Remember how I said vertical angles we're going to use a lot? Samesies with transitive. And then the very last thing, once again, they switched it from equal to congruent. The only reason they did that was because they wanted you to specifically say that they are congruent to each other. And so that's why they switched it. And remember, switching back and forth. So this one is always going to use when you switch between equal and congruent. Same thing there and there. Okay, what was the given information? So the given, you're going to write down this, right? This is going to get written right here. What should be marked in the diagram? So in this part, what did we mark? So up in the picture, talk about all the stuff that you marked. Okay? Like, what did you mark equal to each other? What did you color code? So that's what they're asking right here. What is the conjecture to be proved? A conjecture is just like what they want you to prove. And you can get that from right here. The prove. I should use a different color for you. I'll do it blue. So the prove is going to go right down to what was the conjecture to be proved. So that's going to where your prove is go. So write that down there. What title should be put above the two columns? So if you think back about when we did even the solving equations, what did we write at the top of these two columns up here? We wrote statements on this side, and we wrote reasons on this side. So you're going to write that green stuff down right here. Statements and reasons. All right, so after you finish the front, go ahead and open your foldable. So given we have this equation of 6x minus 9 equals 13x minus 16, prove that x equals 1. So let's start by putting our statement word right here. And then we have reasons on this side. Statements and reasons. And we spent a whole day doing this, correct? So step 1 is going to be us putting our equation. So that is 6x minus 9 is equal to 13x minus 16. And what is the reason we are allowed to write that? That would be our givens, correct? Is that the only thing they gave us? Yep. Given. Whoopsie. All right, now we have to go back to our algebra and think about how we're going to solve this.
Step 2.
Oh, goodness gracious. That other old video's playing somewhere weird. Okay, so let's go ahead and put our Mr. Squiggly down the middle. And what are we going to do? Well, we do have x's on both sides of the equation, so we're going to get rid of one of those x's by subtracting 6x on this side and minus 6x on this side. And we get negative 9 equals 13 minus 6 is 7x minus 16. And what is that? That is, remember, whenever we subtract from both sides, that is our subtraction. I'm going to abbreviate property of equality. Sorry, equality. Subtraction property of equality. Why won't that go away? Collapse. Oh my gosh. Okay. Then we're going to do what next? This step right here was us simplifying. Then we did step 4. And we're on step 4. What are we going to do next? We want to get x by itself. So we got to get rid of this minus 16, and we're going to do that by adding 16 to both sides. Negative 9 plus 16 is going to give us 7 equals, and this cancels, and we have 7x. So that was our addition property of equality. And then we have to, then we simplified, right? Do we need to squeeze simplify in here? Step 5, we got that, and that is simplify. And then we did division property, divide by 7, and we got x is equal to 1, right? And so step 6 is going to be division property of equality. And then our final answer is right here. That is really step 7. So step 7 is going to be simplify. And then we look back up at the top. Did we do what we were supposed to? Given the equation, blah, 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 prove that x equals 1. So did we prove that x equals 1? Yep. Did we justify all of our steps? Yes, we did.